Okay, what we're going to talk about, going back to the bond, we're going to actually talk about the point of view from the company that's actually selling the bond. When you actually sell a bond, a company doesn't actually go through and actually sell the bond to people. It actually goes through a broker. It goes through a bank or some kind of institution that will charge a fee. And most of the time, the fee is like a 1% fee to sell the bond. And in this case, we have a company that has went through to sell that $1,000 10-year bond, and it's going to cost them 1% for it. So if we actually drew this out and in the relationship of what it looks like to the company, we see that this is going for 20 periods. Remember, it's 10 years. We're doing it semi-annually. And we have an initial amount of money. We know that the amount of money is $1,000, but the company doesn't get all of that. It gets 99% of that, which is $990. The $10 goes to the seller of the bond as a fee for doing the transaction. They also have to pay out the $40 each period, which is the 20 periods. And at the end of 10 years or 20 pay periods, they have to pay out the face value of the bond, which is $1,000. And what we want to know here is what is the interest rate, effective interest rate that is actually given for paying back this loan, really, if you think about it, because they're getting a loan of $909 and paying out over 10 years the $40 two times a year and paying $1,000 at the end. So to calculate that, we wanted to use the net present worth. We're going to use the present, which is considering the present worth of the benefits minus the present worth of the cost, and that's all set equal to 0. In this case, the benefits, we only have one benefit at times 0, which is the $990 that they're actually getting. Notice it's not the $1,000 because there's a transaction fee that's actually being caused of 1%. And we want to take off the cost outlays or costs that we have, and that is the $40 that is the annual that is occurring every 6 months. And we're going to find a P given an A and I for 20 periods. And we're also going to subtract off the $1,000, and we're moving that back to the present from the future at some kind of I for 20 periods. If we actually tack this and put the I at 4.5%, we find out the net present worth in this calculation is around 5508. And what we're looking for is not the 55, we're looking for it to be set to 0. So we continue on, we select a 4%, and we find out the net present worth in this case is a minus 10. So we have now framed it, and we know that our 0 falls somewhere between 4 and 4.5%. So by interpolation, we find the internal rate of return, which is in the case the I for the compounding period, which is every 6 months, is equivalent to 4.077%. We also can say that the nominal rate in this case is equal to 8.154%. Okay, and then the effective is equal to 8.32%. And just remember how we actually got those. We used the formula on this one, R equals IM, and in this one we used IA is equal to 1 plus I to the M minus 1, and for this one we know that the interest rate is 4.077 and multiplied times 2, and this one is 1.0477. Whoops. And it's going to be raised to the second power. All right, so this is basically what we have, but make sure that you know how to actually go through the effective, nominal, and also the internal rate of return or the interest rate per compounding period.